Hello and good day. In pre-algebra, we're covering PO15, simplifying algebraic expressions. And the goal today is to learn some skills, well, also learn about the parts of an equation and what you'll kind of see, but then learn some skills that will allow you to better solve equations once we get to those starting in PO18 and forward. So you'll notice I'm beginning here with some pictures. And it says, look at each group of objects and then write each group as an expression. Okay, so this first group, I've got soccer balls and basketballs. Okay, so if I wanted to represent a soccer ball with an S, I might say that this expression would be a soccer ball plus a soccer ball plus a soccer ball plus a soccer ball, and then maybe plus a basketball, B for basketball, and there. Okay, so S plus S plus S plus S plus B plus B plus B. The whole point of simplifying an expression through combining like terms is to write this same expression, write this same idea, but just a shorter, more concise way. Okay, rather than saying S plus S plus S plus S, what could I instead write? Aiden?
4S plus 3B.
Right. I've got 4 soccer balls. Right? I could represent that as just 4S. Okay? Instead of 1 soccer ball plus 1 soccer ball plus 1 soccer ball plus 1 soccer ball, I've got 4 soccer balls here. And then Aiden also said, then you could put 3B to represent your basketball plus your basketball plus your basketball. Okay? So the simplified expression for what I have here would be 4S plus 3B. Now, why can't I combine the 4S and 3B? Why can't I go any further here? Noah? Right, because they're not what are called like terms. You see that's one of your definitions further on down in the line here. Okay, a soccer ball is a different thing than a basketball. They can't be grouped together and say I've got 7 soccer balls, soccer. It doesn't make any sense. Okay, so you have to keep them separate. All right. The second example here, I've got lamp plus chair plus lamp plus chair plus chair plus chair plus bed plus bed plus bed. That's a lot. That's a lot to write. Okay. Combine the like terms here, or the like objects, and give me the simplified expression. Rather than saying 1 lamp plus 1 chair plus 1 lamp plus 1 chair, how many lamps do I have? How many lamps do I have? 2. So I can write 2L. 2 lamps. Plus what? G.
4 chairs.
Plus 4 chairs. Plus what?
3 beds.
3 beds. Okay? 2L plus 4C plus 3B. It doesn't matter that my lamps aren't right next to each other. Okay? I can still, how many lamps do I have in all? I've got 2. Okay? And so what we've just done here, and you see these definitions here, we start with term. Okay? A term is a part of a mathematical expression. Okay? A term is a part of a mathematical expression. And terms are separated, so you should all be putting this down now, right? Here's the notes. You all jump in here. Terms are separated by addition and subtraction. Okay? A term is a part of a mathematical expression, and they are separated by addition and subtraction. So if 4S plus 3B is my expression, how many terms are in that expression? 4s plus 3b. How many terms are in that expression? John?
3.
Not 3. There are 3 in my second one, right? 2l plus 4c plus 3b. There are 3 terms. What's that? I'm talking about the first one.
Oh,
2, yeah. So we got 4s is one term. Positive 3b is a second term. That addition sign separates those 2 terms. So the 4 multiplied by the s, that's one term. Okay? The 3 is connected to the b, that is one term. Right? Here, 2l, positive 4c, positive 3b, that expression has 3 terms. Okay? Originally, in this expression here with my lamps and chairs and beds, I had 1, 2, 3, 4, 5, 6, 7, 8, 9 terms, right? We were able to simplify that down to 3 by combining the like terms. So let's jump down to like terms here. How would you define like terms? Why are we able to combine L and L to make 2L? Or C, 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 and C to make 4C? What makes them like terms? Aiden? They have the same, what? Thing? Same thing, okay. Mathematically speaking, though, what do they have the same of?
They have the same like letter coming after them.
Same variable, right? The same variable. So like terms are terms with the same variable, and that's why we were able to combine L and L to make 2L. It's the same thing. Why we're able to combine C, 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 and C to make 4C. And it's why we can't combine 4S and 3B. They are not like terms. They do not have the same variable. So we have to keep them separate. Okay? What's a coefficient? That may be a term that you've heard before. What is a coefficient? Anybody know? Coefficient? Aiden?
Something that like.
That's okay. Okay. The coefficient is the number that comes before a variable okay. So the number that comes before a variable, and its purpose is it tells us how many of the variable we have. Okay? So what it is, it's the number before the variable. What it does is it tells us how many of that variable we have. Okay? We can see by the picture that we've got 4 soccer balls here, right? We can count them up, 1, 2, 3, 4. But when we simplify that expression to be 4s, that 4, the reason why it's a 4 is because there are 4 of them. It tells us how many soccer balls we have. 3 basketballs, that's why it's a positive 3. Okay? How many chairs do we have? We can count them up, or we can just look at the coefficient to our variable for chair. We have 4 of them. Okay? So it's the number before the variable, and it tells us how many of the variable we have. What about a constant? Anyone know what a constant is? No? A constant would be a number without a variable. Okay? A number without a variable is a constant. We don't have an example of one up in our expressions that we have up here. Every term that we have has a variable attached to it, but we do have some examples down below this in our practice section, so you'll get experience with those. But a constant is a number without a variable. And down again to our like terms here, I've got one more thing to add to that. Like terms are terms with the same variable. And then in parentheses, you might want to add that constants are also like terms. You can make it fit. Okay? So like terms are terms with a variable, but with the same variable, but constants, since they don't have a variable, they're also considered like terms. Okay? And then to simplify an expression is exactly what we did up at the top here. Writing 4s plus 3b is simplifying that expression. 2l plus 4c plus 3b is simplifying that. To simplify means to combine all of our like terms. Okay? To combine all of our like terms. That's what it means to simplify. Combine like terms. Yes, sir?
What constant do you like term if you have like two constants?
Yes, that's why we added that here. Yep, constants are also like terms. If you had two constants, you'd be able to combine them. Okay? You can think of constants, being without that variable. It's like they're constantly alone, just like Mr. Schultz on a Friday night in high school. That was a joke. Okay, that's our definitions. Hopefully I didn't give you a wrist cramp going through all those. But anyone else need these notes? Or are we ready to move on and start to practice? Okay, if you need them, you can refer to the video. So down we go, and it says, in each expression below, circle the coefficients, box the constants, that means put a little square around them, and underline like terms, then simplify the expression. So 3x plus 4x plus 4x minus 9. First of all, how many terms does that expression have? How many terms? 3. 3x, positive 4x, negative 9. One of the biggest mind shifts that you need to make going from elementary math into pre-algebra is that, that subtraction sign, that minus 9, that subtraction sign belongs to the 9. So if I ask you, what's our constant here? You wouldn't tell me 9. Our constant is a negative 9. Okay? Our constant is a negative 9. It's doesn't have a variable, which makes it a constant, so I'm going to box it like the directions say, but you need to include that sign with it. The subtraction sign kind of doubles as the sign of the number that comes after it. It belongs to it, so that is a negative 9. Okay? Our coefficients, which we're going to circle, we've got 3. Don't circle the x. The x is not a coefficient. It's a variable. And then circle positive 4. Just like with that 9, that plus sign makes that 4 positive. It belongs to it. So you should circle the 3, circle positive 4, and then box negative 9. Okay? Now, what terms can we combine here? What terms in this expression are considered our like terms? Our like terms. Carly? 3x and positive 4x. Why? Because they both have that same variable. They both have an x. Okay? And how many x's are in that expression total? We have 3 of them. We add 4. Total, that is 7. So the simplified way to write this expression would be 7x minus 9. Okay? We can't combine 7x and negative 9 because the negative 9 doesn't have any x's with it. They're not like terms. But the 3x and the 4x are. Total, how many x's do we have? 7 of them. Okay? The next one, 11 plus 8n minus 5. 11 plus 8n minus 5. How many terms? How many terms? Everyone just hold up a number. 1, 2, 3, 4, 5. If it's more than 10, hold up a foot. Okay? How many terms? Right, 3. 11, 8n, negative 5. Okay? Do we have any coefficients? And if so, what? John? Negative 5 is not a coefficient. Remember that coefficient is the number that comes before the variable. It tells us how many, in this case, n's we have. 8. 8 would be the coefficient here. And when we circle this, we're going to circle both the 8 and that plus sign, right? Because that sign belongs to it. And then how about constants? We're going to underline, no, box our constants. What are our constants here? Ifan? Good. -5. That negative sign belongs to it. And 11. Okay. And now, finally, what are the like terms that we can combine here? How can we make this expression simpler? What are the like terms that we can combine? Jacob. 11 and -5. What is 11 minus 5? What is 11 minus 5, Carly? +6. So this is why it's important to remember that's a -5 there. Okay. When you combine those, you are just going to take 11 minus 5, which would give you 8n plus 6. Since 11 minus 5 is a +6, when you write that, you're going to write it as +6 because that plus sign, remember, doubles as like a positive symbol. It would not be incorrect to reverse this and write 6 plus 8n, right? That would be fine. Those two expressions mean the same thing. Both of them have a +8n and a +6. Usually, when you've got a variable term, that'll come first. So you'll see this much more frequently as the top one than the bottom one, but both are fine. Both would be correct. I would accept either of those answers. Okay? Questions so far? You with me? At least in shouting distance? More or less? Are we all playing the statue game? Because if you are, you're all winning. Okay, all right. Third one, 2y plus 9y plus 13 minus 13y. What are the coefficients that we're going to be circling? 2y plus 9y plus 13 minus 13y. Maybe? 2, +9. And rather than saying the second 13, is it the +13 or the -13? -13, yeah, which is the second one. Good. Those would be our coefficients. They tell us how many y's we have. We have 2 of them. We get 9 more, then we lose 13. Okay? And then that +13 would be our constant. It does not have a y. It's just by itself. What are the like terms? What are the like terms? What are we able to combine here? Like terms, Aiden.
14n, 8n. Oh.
We're on the third one.
2y, 9y, and 13y.
2y, 9y, and what?
13y.
-13y. I'm going to be a real stickler about including that sign with it. Because if we're combining 2y, 9y, and 13y, that would mean that you're adding 2 plus 9 plus 13. Right? That's not what we're doing. We're taking a +2. We're adding 9, which is 2 plus 9, 11y. And then we're subtracting 13y from 11y. A +2, a +9, and a -13 would be 2 plus 9 minus 13, which gives us -2y. That's why that sign is so important. Okay? It's not 2 plus 9 plus 13. It's 2 plus 9 minus 13, which is a -2. And then our constant, which happens to be plus 13, just tags along. Can't combine it with the variable term, doesn't have y, no other constants to combine it with, and so there we have it. Okay? Pick one of the next 6 to do together. One of the next 6 to do together. Noah. Of course, I should have predicted that. So we have 4x minus 7y plus 2x minus 9 minus 3x plus 13y. Woo! How many terms? 6. Okay? 6. Remember, terms are separated by addition and subtraction. So we have 6 terms here. What are our coefficients? What am I circling? Coefficients, Connor. Not the x though, right? Just that 4.
Sure, 4, 7, 2, 13.
Okay. I heard you say 7 and 3, but I don't see a coefficient of 7 and 3. Sasha? -7 and -3. Okay. Those signs have to be mentioned. They belong to it. It's a -7y. And then our constants, which we're boxing, we got one of them. That is a -9. Okay. So now we look for like terms. With two different variables here, with an x and a y, just like in our examples with the lamps, chairs, and beds up above, I combine the variables that are the same. Okay, I can't combine a lamp with a chair. That'd be a champ. Actually, be a brilliant idea. I'll table that. And I can't combine an x and a y here. So my like terms with this 4x would be positive 2x and negative 3x. Then I actually have a second set of like terms, this negative 7y and positive 13y. Okay, so when I'm all done here, I'm going to have an expression with 3 terms. I'm going down from 6 to 3, an x term, a y term, and then a constant. What is my x term after simplifying? Positive 4x, positive 2x, and negative 3x. How many x's do I have in all? 3 of them. Positive 4 plus 2 is 6, minus 3 gives me 3x. Then my y's, negative 7y, positive 13y. What's negative 7 plus 13?
-20.
Nope. Remember back to PO3, go the right way. Negative 7 plus 13, right? We're starting at negative 7, and we're adding 13, so we're going to the right, right? Negative 7, going to the right, past 0, into positive land. Negative 7 plus 13. A lot of half hands. Not 3. You went the right direction, though. Anyone try?
6.
Positive 6. Okay, that's why PO3 is a PO, right? Because it's something that's going to come back here. Even if you understand how to combine like terms, if you can't add that, then we're going to have problems. So that's the rationale behind why certain things are POs, because they come up again, right? And then our constant, which we can't combine anything with, our -9 just comes along for the ride. So 3x plus 6y minus 9. Okay? How are we doing so far? Got it? All right. Flip over to the next page then. And here's where we introduce something called the distributive property, which I understand that you've learned before. Okay? And the mathematical representation of the distributive property is that if you've got a number, a, outside of parentheses, in which you're adding or subtracting within the parentheses, such as a times the sum of b and c, you are mathematically allowed to distribute that a and multiply by b and by c. So a times b plus c is equal to a times b plus a times c. Yeah. Yes. And the value of doing this is that it gets rid of the parentheses. When you're trying to solve an equation for a variable, parentheses are kind of like a wall. Okay? You can't really go any further until you get rid of them. And this is one method you can use to get rid of parentheses when you've got something set up like we have down below here. Okay? The reason why this works, let's say that we've got 2 on the outside of parentheses, and we're multiplying that by 12. What is 2 times 12? Yvonne? 24. Okay. Now, we could also write 2 times 12 as 2 times 10 plus 2, right? Because within our parentheses, whether we just write 12 or write 10 plus 2, in both cases, we're multiplying 2 by 12, okay? If it's written as 2 times 10 plus 2, what the distributive property tells us is that we can take that coefficient of 2 on the outside of our parentheses and distribute it in so that we are multiplying 2 by 10 plus 2 times 2. Right? That's this property tells us, is we can distribute that 2 into our parentheses and multiply everything in the parentheses by our coefficient. And of course, what's 2 times 10? 20. What's 2 times 2? 4. And 20 plus 4 equals 24. Right? So it's the same value. Okay? Now, if you have 10 plus 2 in parentheses, you'd probably just add them to get 12 and then multiply 2 by 12 anyway. But if you look at some of the expressions we have down below here, we don't have like terms in our parentheses. N plus 7, you can't add those together because one's an n and one's a 7. One's a variable and one's a constant. So to get rid of parentheses here, we have to use the distributive property. I shouldn't say we have to. We're going to. Okay. So that means we're going to take that 8 and we're going to multiply by n and then multiply by 7. We're going to distribute the n, or the 8, into our parentheses. The word distribute means to give to all, right? When your teacher asks you to, please distribute these papers to the class, you give everyone in the class a piece of paper. Okay. Here, everything inside of our parentheses gets that 8. So 8 times n is just 8n. And 8 times 7 is 56. So our expression would be 8n plus 56. And we would now be able to solve that for n once we talk about how, right? So the point of this property is to rid ourselves of our parentheses. 10 times n plus 5. Our coefficient of 10 gets distributed into the parentheses. And we get 10 times n, which is 10n. And 10 times 5, which is 50. Okay. Most common mistakes that folks make is they either forget to multiply everything inside of the parentheses by 10. So their answer would be 10n plus 5. They forget that second term. Okay. That's why drawing these things helps. Second most common mistake is they add instead of multiply. So they might have 10n plus 15, adding 10 and 5 rather than multiplying 10 and 5. Okay. Yes, question. You can't solve them as they're written because we don't know what they equal. You know, if I give you an equation like, you know, n, or I give you an expression like n plus 1, and I say solve for n, you can't do it unless you know what n plus 1 equals, right? As soon as I add a 3 and I say solve for n, well, now you can, right? Because you know what the expression is supposed to equal. N is 2. But without that equal sign, we can't solve it because we don't know what the value is. So we're not solving in this particular objective. We're simplifying, and then from here, we'll add the equal sign and then go to work and solving it. So that would be your final answer here. Let's look at the one right below that. The first one in the second row. -9 times -4n plus 9. My caution to you here says pay attention to signs. They are easy to lose, right? When we distribute this -9 in, we are taking -9 times a -4. So what sign will our product have? -9 times -4. What sign will it have? It'll be a positive. So we get 36n. And then when we distribute here, we've got a negative 9 times a positive 9. What sign will our product have? Sasha? It'll be negative. And what is negative 9 times 9? Negative 81. And how we write that negative 81 is just minus 81. Because remember that negative sign, subtraction sign, kind of a dual purpose there. And that would be our simplified expression, 36n minus 81. Okay? So what I would like you to do for Monday is I want you to finish the front side, the last, what do we have, 5 or so, 4 of them, 5 of them, combining like terms expressions to do. And then I only want you to do these 3 on the back side. I want to talk specifically about those other 2 once you kind of get some practice with just the kind of basics of it. So finish the front side with combining like terms, those 3 on the second page that I've circled. And then, do I want to do any more? No, I think that'll be good. Okay? All right. Any questions, comments, concerns, complaints, compliments, congratulations, or criticisms? Nope. All right, very well. That's how you math.